Hello everyone, this is Lai from the DJL team, and this is the last video of the DJL 101 series. And today we're going to do a summary of what we have learned through this series and let you know how you can continue your deep learning journey with DJL. So first, recap on some DJL basics. We have talked about several things already in this series. So if you have any further questions, you can refer to some of the previous videos, or you can just ask us on our Slack channel. First of all, what and why? So as we mentioned again, DGL is an open source deep learning framework that's in Java. It provides you a simple user-friendly Java API, and same as any other Java program, you can write once and run anywhere. So it's cross-platform as long as you have JVM installed, so you can use it anywhere. And then regarding deep learning, it's framework agnostic. So it's the same Java API for different deep learning frameworks. No matter you're using TensorFlow, PyTorch, MXNet, or even other engines, it's all the same API for you. And we made it scalable, performant, and suitable for production environment, because many of the production environment is using Java or JVM. That's why we built this for you, and so you can deploy it anywhere in your production. So DGL support both inference and training. So you can not only deploy your deep learning model with DGL, you can also train it. If the data is already in a Java environment, you don't have to copy it to a Python environment, a standalone environment to train it. You can directly train it using Java. And uh, because we're in Java, and many of the big data solutions are built in on JVM, we have a tight integration with this big data ecosystem. So for example, Apache Spark, Kafka, Flink, and then Beam, they're all in JVM. And DGL naturally has a tight integration with them. Next, how to actually run it, how to set up DGL and install it. So um, there are several ways to use it. First is like any Java package. So you only need JDK installed. We require JDK 8 and plus to use DGL, and you can use it either using Gradle or Maven. I'm sure if you're a Java developer, you're already familiar with these two build systems. You can just add DGL's package in your project, either using Gradle or Maven, and then you can import it and use it. So we provide many packages pre-built for you. First, you will need the DGL API, and then you can choose one of the engines you prefer according to what your model is. You can choose TensorFlow, PyTorch, or MXNet, and some of other engines are available as well. Once you added those dependencies, the package will be automatically downloaded for you, and then you can just import it and use our APIs in your program. Another way is you can build from source if you want to make modification to our code and to suit your needs. You simply just need to git clone and then Gradle build. That's it. Simple as that. Then you can load it in your IDE like IntelliJ or Eclipse. Just open the project and then you can make whatever modification you want. If you have any further questions, you can refer to our documentation website, our quick start on how to install, and there is already a video about it. Now, there are many new concepts in deep learning, and in order to help you understand it, we built different packages and APIs that's easy for Java developer to understand. But still, you need to learn about these concepts, and let's recap on some of them. So the first and most important is ND array. It means n-dimensional arrays. It's a multi-dimensional container of items of the same type and size. So because in deep learning, the data is massive and usually in multiple dimension and in batches. So that's why we designed this container concept to help you better manipulate or control the data. So this API supports array creation and mathematical operations. It can help you generate a random number or a large group of number all at once with one command. And then you can operate on those data, you can manipulate them, like reshape how it's organized. You can do mathematical calculation, add, minus, plus, and some other higher complex operations. And then it has a unified Java interface, but the good part is it's hardware accelerated. So in front of you is the same Java API, but behind it, it's actually written in C++ in different deep learning engines. And with the benefit of efficient and performance from C++, we can leverage many of the hardware accelerations. On CPU, Intel CPUs, we have MKLDN, that's a deep learning math kernel for accelerating deep learning operations. On GPU, we have CUDA built by NVIDIA. And then we have some of edge solutions as well. So you can run DJL on edge devices with limited memory and CPU resources. So here is an example of how you can create a ND array. So you can have an ND manager that manage all the ND array life cycles, and then with an ND manager arrange, you can create a list of numbers with one line. So just arrange 12. It will generate 12 numbers from 0 to 11. And then you can operate on top of it. As you can see on this example here, you have X and Y with specific numbers when you create them, and you can add them together to view the results. Next, let's talk about some basic deep learning concepts. I'm sure you already have learned it, and let's just recap the most important concepts. So we learned about basic training process. It consists of model building and how to define training loss, and you have to run forward and backward propagations to update to your model weights. And then you need to run some evaluations to evaluate how your model is performing, how accurate it is. And then maybe you need to iterate on your model and do the whole process again. So we provided the block APIs to help you construct neural networks. It's very simple, and it supports various model building semantics. You can using a sequential API, or you can use a Lambda block to build different types, different architectures of neural networks according to your needs. And then there's the trainer API. So it can help you facilitate the training process. You can, define loss in your training. You can define how you want to monitor the training process, like what's the accuracy, what's the loss, and what other metrics you want to monitor during the training process. And then you can, say how you want to optimize your model using optimizers. And then we provide you a progress bar to show you real time how is your model performing. This all included in our trainer API. In addition to that, we have built DJL 0. So it's meant for developers with zero deep learning knowledge to get into the deep learning world quickly. So you can leverage some of our pre-built models to run training, and you don't have to know too much details about all the things I've talked about. You just need to define your problem domain and provide us with your data and how you want and tell us how you want to deal with your data. We will do that automatically for you. So what now if you already have a model and you want to deploy it? That comes in inference or prediction. DJL provide very easy API to allow you to deploy your trained model into Java environment. No matter whether your model is trained in Python or whatever framework you choose, you can deploy it in Java. So we have the predictor API to help you make predictions on new data with a already trained model. And we have a translator API that encapsulate input pre-processing and output post-processing for you. So you can translate your input to something meaningful that the machine understand or the model understand, and run the model prediction and get the output, and translate the model output to something humans can understand and return it to you. We also give you the Model Zoo API that contains a lot of pre-trained models that you can use directly. It's categorized according to their applications, like computer vision and natural language processing. And under computer vision, there's image classification, object detection, etc. Under natural language processing, there's embedding, machine translation, and etc. So with all this, we have lots of state-of-the-art models available ready for you that you can download and then run inference directly or do some transfer learning on it. Now that you have a lot of model available in the Model Zoo, you can also launch DJL model serving using just one line. You can launch a web server that hosts the model you want to serve, and then you can make inference calls or prediction calls using REST API to a web service, and it will return you the result. So it's really the one-stop shop for deploy your deep learning models anywhere. So besides model serving, DJI is also tightly integrated with big data pipelines like Apache Spark, Flink, Beam, Camel, and Kafka. So you can deploy your model in big data environment very easily. So with that, that's all of the DJL basic concepts. And we finished our summary of the DJL 101 series. Next, we're gonna let you know how you can continue your deep learning journey with DJL.